सर आपकी आवाज भी कट रही है।
Uh, is it any better now?
शायद नेटवर्क प्रॉब्लम हो सर, आवाज बहुत कट कट के आ रही है आपकी।
आपकी बिल्कुल क्लियर आ रही है मुझे. Okay, let's begin. I was telling you that we had discussed types of polymorphism. Compile time polymorphism we have already discussed, including function overloading and operator overloading. The last topic that we had discussed last time, it was overloading unary operators. So today we'll discuss runtime polymorphism, which is implemented through virtual functions, right? It means at the time of execution of the program, the call to a function is bound to a particular definition. It is done at the execution of the program. So this is a little technical topic, so we need to know a few basics about pointers. So let us discuss pointers first. As you can see here, I have declared two variables, integer I and character C, and the two pointers. One is integer IP, second is character CP. So if I write IP is equal to address of I, and then I write CP is equal to address of C, then it is perfectly valid. Can anybody tell me what is the pointer? A few things about pointers we need to discuss first. Anybody, what is the pointer? Somebody say something. What is the pointer? A pointer is a special type of data structure that contains address of some other variable, right? Or technically speaking, a pointer is name of a memory location where you can store address of some other memory area. For example, in this particular case, I have declared integer pointer IP. It means IP is a memory area which will contain address of some integer. So since a pointer will always contain address of some other data member or some other variable, pointer has a fixed data type because it is going to store address, right? So its data type is, let me just write it for you. Data type of pointer is always unsigned integer because it stores address of some other variable. That's why the data type of the pointer itself is always fixed. It is unsigned integer, right? Then what is the meaning? For example, if I have declared a pointer like this, pointer IP, integer IP, it means IP is a pointer that will contain address of an integer, right? Like here in the program, what I have done, I have stored address of integer in IP. It means when we write here int or char or whatever else we are writing, we simply mean that the address that will contain in IP, it will point to how many, or it will contain how many bytes. For example, in this case, it will point to 4 bytes. We had assumed that integer is of 4 bytes. So if I declare a character, then it will point to 1 byte, right? Minute. I'm getting a call from the department. Let me just attend that. Okay, it's gone. Fine. So what we were discussing is, if it is integer pointer, it will point to 4 bytes. If it is a character pointer, it will point to 1 byte. What is important? Size of IP or CP, they are both the same, 4 bytes, unsigned integer. So like in this case, once again, this is valid because to integer pointer, I am assigning address of an integer, and to a character pointer, I am assigning address of a character. There's no problem. But if I change the values, for example, to integer pointer, I assign address of character, and to character pointer, I am assigning address of integer. Is there any problem in this, or is it valid? Anybody? Of these two statements, is any statement valid or not? Anybody? Yes, anybody? I'm not getting any responses. Why? One is valid, the other one is not. The first one is not valid because a larger pointer, you need to remember this, that it is invalid because a larger pointer can't point to a smaller memory area. However, the other one is valid. Why? Because a smaller pointer can point to larger area. It is possible, right? So the first one, when we are assigning address of a character to an integer pointer, it is not possible because integer pointer will point to 4 bytes, whereas character address it will contain only 1 byte. Whereas in second case, an integer address can be assigned to a character's address because character will point to only one byte, and to that CP character pointer you are assigning address of 4 bytes. So it is valid. It works. Though it is giving error here, but technically it is correct. It can be done. Now coming to dynamic polymorphism, let us create a base class. Let me declare a variable in it. Let it be some I, public base I is equal to 10 or whatever we want, and void display out I and that. And let us have one more function, show, which will basically do the same thing. Out I, no difference. So far, there is no difference between these two. Now, using the base class, let us create a derived class. Last time I had told you that if a base class function is defined again in derived class, it's called function redefinition. Similarly, writing again two functions, cout and here derived I is equal to 20, and here we'll make it protected because if it is public, if it is private, it won't be accessible in derived class. So these are two small classes, base class with a constructor and two function display and show, and derived class with the constructor and two functions, same function display and show. So here we have function, this is function redefinition. This is also, so far this is also function redefinition because the base class function is defined in the derived class, so it is simply function redefinition. Now, if I create a base class object and if I create a derived class object, and then I call object b dot display and object b dot show. They are the same. Their functionality is the same. Object d dot display and object d dot show. Let's run it once. The output will continue. It's much expected. This is what was expected. Then for display and show of base, it will display 1010. For display and show of derived, it will display 2020 because in the constructor of derived class, we have modified the brand.
Excuse me, sir.
Yes.
The voice is not clear.
Oh, I'm trying.
कट हो रही है बीच बीच की वॉइस
Is there any break in voice?
यस सर
There might be some problem of network. Let me just check mine. No, mine is good. Some of you may be, is everybody having the same problem with my voice? Otherwise, some of you may be having some problem of network.
Yes, sir.
Yes,
Is it
sir.
not clear?
Yes, sir.
Everybody is saying it's not clear. Okay.
Yes, sir. Not clear, sir. Voice not clear.
Wait a minute. Wait a minute. Let me try to change my network. 1 minute. Yes. Is it any better now?
Yes, sir.
Can you hear me?
Yes, sir, we can hear you.
Is it better? Is it any better now?
No, sir.
Sir, it's not clear
What is the
yet.
reason? I have changed my network settings also. I think it should have worked now. Yes. Now, once again, please check. Let me know. Is it any better now?
No, sir. Same problem, sir.
I don't know what's the problem here because I'm using the best possible available net connection here. Okay, let me just try again. If there's again problem, then let me know. We'll try to resolve it somehow. Okay. So I was telling you that in derived class, when you define the base class functions again, that is function redefinition, right? I'm going to make a small change here. Okay, I'm going to make a small change here. I'm declaring first function as virtual function, right? Will it have any effect? Let's see. You can see there is no effect at all, no change at all. Okay, now instead of this writing virtual function, let me try to make a change here. Base pointer ptr base and derived pointer ptrd. So pointer base is equal to address of object of base and pointer derived is equal to address of object of derived. So far we have not done anything wrong, or to the pointer of base we have assigned object address of object of base, and to the pointer of derived we had assigned address of object of derived. So pointer of base display, pointer of base pointer of derived display and pointer of derived. Let's see what happens now. Again, no change. Fine. Now I am going to make a small change here. Instead of derived pointer, right here, what I am going to do to the derived, to the base pointer, I am giving address of object of derived. I had told you, look at this. I'm drawing two circles here, right? Can you tell me which one is inner, which one is base and which one is derived? Anybody? Of these two, which one is base and which one is derived? Yes, anybody? Of these two circles, which one is base and which one is derived?
Sir, outer section is base and the inner section is derived.
Okay, anybody else? Which one is base, inner or outer? Yes, anybody? Anybody else?
Same idea, sir. I think the outer one is base uh, and the other one is
Other one is derived. Okay, anybody else? Any different view? Okay, look at it. Let me change the view a little. This is a base class, right? Let me name it base. Okay. To this, I am going to create a new class which is derived. I hope you remember I had told you this derived class will inherit all the properties and functions of base class, right? So derived class will have larger size. Is this thing clear? Is this thing clear?
Yes, sir.
Larger size. So it means inner is base, outer is derived. Size of outer is larger. Is it clear to all of you? Yes. Is it clear to all of you?
Yes, sir.
yes,
Yes,
sir.
sir.
Okay.
Yes.
Then I told you that to a character pointer you can assign address of an integer because integer is larger and character is smaller. Similarly here, have a look what I have done. To a pointer of base, base is now smaller and object of derived will occupy more space. To a smaller pointer, I am giving address of a larger data type, then it is valid. But what will happen? You need to see here. Remember, I have assigned address of object of derived to pointer of base. See what will happen. It is showing 2020. Is it clear? It's showing 2020. I'll make a small change here now. Virtual. And then run it. Let me run it again. It is again showing 2020. Mm, Now I'll make a small change here. I am removing all these constructors, and let me write something here else here. Base constructor. This is what we had done earlier also, and base here I'll write derived constructor, and here derived destructor. Run it again. Base constructor and base. Oh, wait a minute. Wait a minute. These are not constructor destructors. Just a minute. I made some mistake here. Just a minute. Oh. Wait, these are not constructors. These are general functions. So let me write this of base and show of base. Here, let me write this of derived and show of derived. I think it's better now. Okay, now both the functions in base class are redefined in derived class. Have a look at it once again. To the pointer of base, we are assigning derived object D. Okay, to the pointer of base, we are assigning address of object of derived. I told you earlier it is possible. So now let us see what is the outcome. Have a look. We have assigned address of derived to pointer of base, but still it is calling the base class functions only. Right? The reason is this: in base class, since you are using pointer of the base class, and here, if you look at the diagram here, there is a kind of relationship here. We say that derived is a base. In base class, as you can see here, in base class, we have these functions display and show. So when you will call these functions through pointer of base, doesn't matter what kind of object you have passed to it, it will first call the base class function. Now I am making one of these functions as virtual, the first one.
सर आपकी वॉइस क्लियर नहीं आ रही.
But I am trying my best. Can we have the class again in the evening? Can we have class in the evening again in that case, if it is still not clear?
Sir, not clear but understandable है.
I don't know what's the problem. But I mean, network is fast here. I am at home. Department में problem थी या नहीं है?
Sir, समझ पा रहे हैं बस.
If all of you are facing problem, we can reschedule the class a little later. Because I have tried
Yes,
whatever I
आवाज
could.
कट के आ रही है आपकी सर.
नहीं, अगर समझ आ रही है, then we can continue. If there's any problem in understanding the concepts, then we can reschedule the class.
सर समझ आ रहा है.
सर समझ आ रही है सर.
Okay. Otherwise, if there is any major problem, then let me know. If it is something minor, then you can watch the video later on, right? Probably the video will be clear. I'll share it. So what I was telling you that if we declare one of these functions, one of the base class functions as virtual, let's see what is the output in that case. And you need to understand the difference. Look here. Display of derived, because now it is a virtual function in base class, and show of base. show function is not a virtual function. So if a virtual function of base class is redefined in derived class, we call it function overriding. Okay, this becomes function overriding. If normal function is redefined, then this is simply function redefinition. Now, what happens in this case? You need to understand this very well. What will happen? We have declared virtual void display in base. Now, if there is a function, okay, one more thing before discussing it, one more thing. Have a look at the class base. What is its size? Anybody? There is no data member, right? There is no data member at all. What is the size of this class then? Anybody? It's an empty class, right? What's the size of an empty class? Anybody? Do you have any idea? Let me write it for you. P out size of base. I told you that in base there is no data member, right? It is an empty class. It is called an empty class, but still the size of empty class is not 0. I'll show you. Let me run it once. Size of the empty class is always 1. Is it clear?
Yes, sir.
Okay. Now what I am doing, I have declared one function, display function, as virtual. Look at the size of the class once again. Look at the size. What's the size now? Earlier it was 1. Now it is 4. Just because I have declared one of the functions as virtual, the size has changed from 1 to 4. Why it is so? You need to understand, and this is the most important thing. So if a base class has a virtual function, then a virtual function table, okay, let me write it. Virtual function table is created and a virtual function table pointer is created in the base class that points to virtual function table. Now what will happen? A table will be created for base class and name of this function will be stored in that virtual function table. It will be created somewhere in memory and address of that virtual function table will be stored in the base class. So since we are storing an address, it is implicitly done. We are not declaring any variable for it. So since it is storing an address, it will be a pointer. So pointer size of the pointer is 4. That's why a new implicit pointer is created and which contains address of the virtual function table. That's why the size of the class is 4 now. Is this thing clear? Yes, is this thing clear? Okay, I assume it's clear. So virtual function table. Let's imagine that this is a virtual function table and we have stored a function display in it. When you will call a function like here, when the function is called through pointer of the base, first it will go to virtual function table if it is there. It will try to search that in virtual function table. If it is there, like here, the function display is virtual, so its entry will be there in virtual function table. Then the system will try to search for its corresponding definition in the derived class. As you can see, the display function is overridden in derived class, so that overridden function will be executed. It will here overridden function will be called. Right. So I repeat, when you are calling a display function through base pointer, first it will check, is there any virtual function table? If there is a virtual function table, then it will search for the definition of the called function in it. Yes, it is there. If it is there, then it will search its corresponding definition in derived class. In derived class, we have a display function, so this display function will be called. Then when you are calling show function, since its entry is not there in the virtual function table, the show function of base class itself will be used. Let me run it once again. As you can see, for display, it is calling display of derived, and for show, it is calling show of base, because show is not a virtual function. Now, if I remove this definition from here, going back to it, when you are calling this function, first it will go to virtual function table. If the definition is there, it will go to the derived class. If the definition is there in derived class, it will be executed. Otherwise, system will execute the base class definition of display, because it could not find its definition in derived class. Let's have a look at it. We have removed the definition of display function from derived, so it is calling display of base, show of base. Is this thing clear? Yes, is this thing clear?
Yes, sir.
Okay. Okay, this is called, now I hope you understand the difference between function overriding. It is the case when the derived class function is defined as virtual in base class, and it is simply function redefinition when a normal function of base class is defined again in the derived class, right? That is function redefinition. Overriding is the case when a virtual function of base class is redefined. This is the basic difference. Okay. Then we have, why do we use this virtual functions or dynamic polymorphism? Think of a shape, right? If I ask you to draw a shape, what will you do? If I ask all of you to draw a shape, what will you do? What shape will you draw? Anybody? Which shape will you draw? Until I very specifically tell you to draw a rectangle or a line, a square, a circle, an ellipse or something, you won't be able to draw a shape unless or until I tell you a specific shape. So it may be rectangle, it may be square, it may be triangle, it may be a circle, it may be anything. But each shape can be drawn, right? Each shape can be drawn. So what we can do, we can make a general class. This is a generic class shape, which will have a draw function. Through this shape class, we will create different types of further classes, rectangle, square, triangle, circle, which all can be drawn. So let us take up this example. I am trying to explain you why do we use dynamic polymorphism. Using this, let me create a class rectangle derived publicly from shape. Keep the things very simple. I am not including many functions. Draw rectangle. Okay. Similarly, let's have only one more shape class. Now look at this. Rectangle and rectangle and circle both are of type shape. So we should have a common interface through which these two can be used. Rectangle can be drawn, circle can be drawn. You can even include area function or parameter function. You can include if you wish. But for the sake of simplicity, we are using only one function. So now let's use this here. Object of shape. Let me declare a pointer to this. Then we have rectangle R and circle C. Object of S is equal to address of R. Object of S, I'm calling the draw function here. So that object of S is equal to address of C, that is circle. Object of S dot draw. Let's see what it will do. It will say draw rectangle and draw circle. Okay. Now, abstract this shape class is an abstract class. Abstract class means it itself has no meaning, right? This shape class is abstract class, means it cannot have a concrete object of it. Like if I ask you to draw a shape, you'll ask me, be specific, what kind of shape? So shape is a top level class through which we will create other classes which belong to shape. So what should we do? We should restrict that its draw function should not be called. So we'll put it equal to 0 statement here. What is the meaning of this now? It means this function draw, which is declared virtual, is actually a pure virtual function. When we declare a virtual function as pure virtual function, then the corresponding class which contains the pure virtual function becomes an abstract base class. Now, what is the effect of this? If I try to create a object of shape, simply S let it be, it will not be possible. It will give me an error message that abstract type shape is not allowed. Objects of abstract type shape is not allowed because it contains a pure virtual function. Means it is for the purpose of inheritance only. You cannot use it for any other purpose. You can create other classes based on shape, but you cannot use shape class directly. So this becomes a pure virtual function when you equate it to 0, and a class containing at least one pure virtual function becomes an abstract base class. Is this thing clear? Yes, Bache, is this thing clear to all of you?
Yes, sir.
Okay. We'll stop here. I'll share the video with you in a few minutes. Go through the video. If there is still any problem, we can repeat this class. No problem. Okay?
Okay, sir.
Go through the video and let me know if there's still some problem. The class can be repeated. No problem. Otherwise, tomorrow we'll have the class at same time, and all of you must try to join in time. Many of you get very late. Okay, take care.
Thank you, sir.